Hello, this is Mike Brown. I'll be introducing the Gaussian mixture models. A mixture model is a classification technique similar to KNN that is identifying subpopulations within a data set using probability distributions, opposed to a distance function like KNN. A Gaussian mixture model is using the Gaussian distribution, the normal distribution, which can be described using this formula here at the bottom and can be demonstrated through this graph here. So, for example, you have this set of data which clearly has two different populations, but you can't describe it by just one distribution, so you have to put those two distributions together. You've got the weight of population 1 and the weight of population 2. The weight is just how many of the data points fall within each group of data. Say it's 50% here, 50% there, 60 and 40, and then you've got the distribution for each population. So if you know the average and you know the variance, so the average and standard deviation, then you can calculate the probability that a given point falls within that data set. So this is great, and so this sort of describes the end state when you're starting and you just have a blob of data. Then you're not going to know the weight, you're not going to know the average, you're not going to know the variance. So in order to estimate those parameters, you use a function called the expectation maximum algorithm. And there's a whole bunch of math that goes into that, but in general, just to summarize, you would set the initial parameters. So for this example, maybe you set the average to be 52, and you set the average over here to be 129. You set the variance, so say it's 5 over here and 10 over there, and then you set the weight for each population, and you just go 50% of the population here, 50% of the population there. So now that you have the average and the variance, you can calculate the likelihood using these distribution functions and sort of these percentages here that 0.66, what's the likelihood that 0.66 falls in this population? Maybe it's 5%, and then what's the likelihood it falls in here? It's probably 0%. So you're going to assign a 0.66 to this population. You do that for every data point in your data set. You assign them either to population A, population B. Once you do those assignments, then you can recalculate the average. So these 100 data points are here, these 400 over here. Recalculate the average, recalculate the variance, and say it comes up to, instead of 45, it's 47. Instead of 129, it's 123. And then you keep iterating that until you eventually, stop making changes and you converge to a result. And once you converge, then you've got your average, your standard deviation, and you've essentially described both of these Gaussian curves. So the pros and cons of the approach. You're using sort of this maximum likelihood, so you're kind of not as bound by geometric shapes as you are with distance functions. It seems pretty quick and pretty easy to build, so it's being used more and more with large data sets, and it's got a limited amount of user input. Outliers and non-normal data really mess with this thing, and when you don't have enough data in the model, it's tough to converge. Some use cases of this are for voice recognition and biometrics, so identifying who a person is, monitoring heart rate variability, so the difference is your heart rate is at any given point from your average or your standard heart rate to predict heart failure and other things like that, and then identifying objects and images. All right, so hope you